Hi guys, so today we're going to take a look at question 2 of the 2017 exam, paper 2. So an experiment measures the fuel consumption at various speeds for a particular model of car, and the data collected are shown in table 1 below. Okay, so the question A in this question, the first part, is calculating the correlation coefficient, but that's just a formulaic process in using your Casio calculator that doesn't change from question to question. So it's not a unique question, similar to constructions. They're not unique. It's just the same every time. So we're not going to go through this here. I'll have a separate video on what those steps are to get the correlation coefficient with any set of data. So we're going to go straight to part B here. So we want to plot the points from the table on the grid below and then draw the line of best fit by eye. Okay, so at 40 kilometers per hour, the fuel consumption per liter is 21 kilometers per liter. At 48 kilometers per hour, the fuel consumption in kilometers per liter is 16. At 56 kilometers per hour, it is 18. At 64 kilometers per hour, it is 16 again. At 72, there is no 72. At 88 kilometers per hour, it is 13. At 96 kilometers per hour, it is 11. So as you can see, there's this gradual decrease. And at 112 kilometers per hour, it is 9. Okay, so we can see that there's this gradual downward trend, which that would be exhibited in the correlation coefficient, which I think is highly negative. Okay, so if we want to draw the best line, then it would be something like this. So something like this, where it's close enough to most of the points, and it captures the overall shape of the graph. So something like this. As long as it doesn't have to be exactly this, but as long as it's close, then it should be fine. As long as you don't have something like this, or something where the line is below all the points. It should be something in the middle. The slope of the line of best fit is found to be minus 0.15. What does this value represent in the context of the data? Okay, so the slope of this line is minus 0.15. So when they ask these questions, it's important to look at, well, what are the units on the x and y axis? And so the x-axis is the speed in kilometers per hour, and the y-axis is the fuel consumption in kilometers per liter. Fuel consumption in kilometers per liter. Okay, so the slope is the rise. So it's the rise over the run. So as we increase speed, so we go forward along the x-axis, speed by 1 kilometer per hour. The average fuel consumption the average fuel consumption or we could also say on average fuel consumption. That actually might be better. So, on average, fuel consumption decreases by 0.15 kilometers per liter, because the run is our speed. The run is the speed, and the rise is the fuel consumption. So as we go forward in speed, as we increase in speed, we move downwards, and the ratio, the rise over the run, is minus 0.15. Okay, so this is all you would have to write here. As we increase speed by 1 kilometer per hour, on average, because this is only the line of best fit, it's not a perfect function for the fuel consumption. On average, fuel consumption decreases by 0.15 kilometers per liter. Now on to part D. I'll just move it up a bit. Mary drove from Cork to Dublin at an average speed of 96 kilometers per hour. And Jane drove the same journey at an average speed of 112 kilometers per hour. Each traveled 260 kilometers because they made the same journey, and they paid 132.9 cents per liter for the fuel. Both used the model of the car used to generate the data in Table 1, which is helpful, otherwise we wouldn't know anything about it. Find how much longer it took Mary to complete the journey than Jane. So Mary traveled at a lower speed, so it took her longer. And give your answer correct to the nearest minute. Okay, so Mary is driving at 96 kilometers per hour. So how long will it take her to go 260 kilometers? Okay. Well, so we have this formula, speed equals distance over time. So if we have the distance and we have the time, then we can get the speed, or we can rearrange this formula. Let's say we have two and we want the other. If we can rearrange this formula to get the other. So in this case, we're looking for time. So time equals distance over speed. We multiply by time and divide by speed. So if we use this formula, then the time taken, let's say Tm, Mary's time, or let's just actually call that T, Mary, is equal to the distance she traveled, 260 kilometers, over her speed, which is 96. And so this equals 65 over 24, or in decimals, 2.708 hours. Because remember, the unit that we're working here is hours. And so then we'll do the same for Jane. So Jane is driving at 112 kilometers per hour. And she also travels 260 kilometers. So if we use this formula again, then the time it takes her, T Jane, is 260 over 112, the distance she traveled over the speed she was traveling on average. And so this equals 65 over 28, or 2.708 0.321 hours. Okay, so if we look at the difference between their times, so it obviously took Mary longer, she was traveling slower, but how much longer did it take? Well, Mary's time minus Jane's time equals 0.387 hours. And then if we multiply this by 60, what is 0.387 hours? To find the amount of minutes, this is 23 minutes. Well, 23.22, but to the nearest minute, 23 minutes. So it took Mary 23 minutes longer to make this journey. Now on to part 2 of D. Based on the data in Table 1 and their average speeds, so Table 1 and their average speeds, find how much more Jane spent on fuel during the course of this journey. Okay, so we know that traveling at a higher speed is less fuel efficient, so it would make sense that Jane, who traveled faster, would have spent more on fuel. But let's figure out how much they both spent. Okay, so let's look at Mary first. She traveled at 96 kilometers per hour, which from the table has a fuel consumption of 11 kilometers per liter. Okay, so she was using 11 kilometers per liter. And so the journey was 260 kilometers. So how many liters did she use? Well, 260 over 11 is equal to 23.64 liters. So she used 23.64 liters. And how much did that cost her? Well, we know that the fuel is 132.9 cents per liter. So if we multiply the amount of liters she used, 23.64, by the cost, so amount of liters times the cost of 1 liter should give the amount she spent. So just total cost. That's the formula that we'll be using here. So the amount of liters, 23.64, times the cost of a liter, 132.9 cents, is equal to 3,141.756. So let's just say 3,142 cents, or 31 euro and 42 cents. Okay, so that's what Mary spent. So let's see what Jane spent. So Jane was traveling at 112 kilometers per hour. And so this is a fuel consumption per liter of 9 kilometers per liter. So the amount of liters she used was 260, the distance, over the fuel consumption over 9 is equal to 28.89 liters. So she used 28.89 liters on her journey. So let's use this formula again to see how much she spent. The amount of liters she used times the cost of 1 liter. So 28.89 0.89 times the cost of a liter, 132.9 cent, equals 3,839 cent to the nearest cent, which is 38 euro and 39 cent. So that's how much Jane spent, and that's how much Mary spent. So how much more did Jane spend? Well, if we just minus how much each of them spent, 38.39 minus 31.42 is equal to €6 and 97 cent. So Jane spent €6 and 97 cent more on fuel during the course of this journey. So she spent around €7 more, and she saved about 25 minutes in time. So maybe it was worth it, maybe it wasn't. But those are the two answers.